right, so let's go ahead and look at the case where we are factoring in two terms. Now this problem is tricky. Z to the sixth minus 1. It's hard to know how you should break this up, perhaps, because we have two different options here. The first option is to think about it as a sum of squares, or a difference of squares, excuse me, minus 1 squared. Or do you do it like this and have it as a difference of cubes? So two options. If you should choose to do it this way, I can tell you that you're going to get an answer that looks pretty strange. You're going to get something in the end that you'll still have like a z to the fourth plus a z squared, and it doesn't entirely look simplified. So if you were to work this one out using this method, you'll get, after all is said and done, something like this. Z to the fourth plus z squared plus 1. Okay. Now, it's not necessarily wrong. It's just not quite maybe as simplified or as helpful as it could be. And this is one of those types of problems that until you start doing it, and you'll see this in future sections, when we start to simplify polynomials, when you start to simplify then, and we call those complex rational expressions, that's where knowing how to factor and knowing what may or may not be most useful to you will matter. So right now, technically, this is also correct, but there is another way to do it, and I would like to show you that method using the difference of squares instead. So, our original problem, as we stated, was z to the sixth minus 1. I've decided that I'm going to factor this using a difference of squares. So I have z cubed all squared minus 1 squared. Okay. Well, we know that the difference of squares says a squared minus b squared is equal to a plus b times a minus b. Okay. So that means that I can go ahead and write this as z cubed plus 1 all times z cubed minus 1. You might be thinking, great, I'm done, fantastic. But if you look at each of these, now we have the case where we basically have a sum of cubes and a difference of cubes. Remember that when you write 1, you could also write that as 1 cubed. Okay? So, I need to continue breaking this down. And the way that we do that is by using the sum of cubes and difference of cubes formulas. First case is this one. Okay? So we're going to look at the sum of cubes first. If you have a sum of cubes, I know that it is a plus b times a squared minus ab plus b squared. Okay. Difference of cubes is a minus b, a squared plus ab plus b squared. Okay. So using those formulas now, we will break each of these down. Okay. Starting with the sum of cubes then, I will have z plus 1, z squared minus z plus 1. You could write 1 squared if that helps you as you're filling this in. Times, then, the difference of cubes. So z minus 1, z squared plus z plus 1. And you can write 1 squared if that helps. And then, of course, you would simplify, and that's what you would be left with. So it is a very long process to solve these. And remember, it doesn't matter which order you do them in, but but certainly this looks much, much different than had we gone with the other route of writing it z squared all cubed minus 1 cubed to begin with and ending up with a very different answer. So, you know, it's just going to depend on the problem and how you may be able to simplify it further. It's one of those things where if you can recognize that you can factor it using two different methods, then it may be worth trying one and seeing how simplified you can get it versus trying another one and seeing how simplified you could get it. Please let me know if you have additional questions on this. It's rare that you see a problem like this that can be factored in this manner. So this is not, you know, the most common type of factoring problem, but you may encounter it from time to time. So great question with this, and I hope it helps. Thanks.